So actual examples of homeostasis. Homeostatic mechanisms regulate body temperature. Body temperature is an easy one to relate it to. And it's very similar to a thermostat in your house. If you have a digital thermostat and you set that temperature at 70 degrees, either the air will kick in if it gets too hot, the heat will kick on if it gets too cold. Your body works very much the same way. Another example would be pressure-sensitive receptors regulate blood pressure. You do not want blood pressure that's too high. You don't want blood pressure that's too low. So you have mechanisms that keep it pretty balanced. Each individual, every person is going to use these mechanisms to keep your body in that homeostasis range. Keep it level. It's going to fluctuate a little bit, but you don't want it out of that normal range. And normal ranges can vary from one individual to the next. Like I said, my average body temperature is lower than average, but it's not that far off. So the way your body does that most often is negative feedback. So negative means opposite. If something happens, your body's going to do the opposite thing. So responses move in the opposite direction of the change. It reduces that change or the variation from that set point. It doesn't want to go too far. And it's going to include some type of mechanisms in the body. So, example. Here, this is in your book. It's on your notes. So, normal room temperature. Here's my thermostat. And it's set at 68. If it's too high, so my temperature has risen above 68, the thermostat detects a change. It's not where it's supposed to be. Heater turns off, air conditioner turns on. This is in your house. Opposite, room temperature drops too low, so it drops below 68, detects the change. Heater turns on, air conditioner is turned off. So this happens inside of your house, inside of your body. So here, normal or average, 98.6. So I'm in the gym, I'm working out, body temperature rises above 98.6. So my body temperature has risen. Receptors in your skin, you have thermoreceptors. They pick up these signals that say, oh, body temperature is rising. The brain gets that message from the receptors. Your brain is pretty much in charge of everything. My body is too hot, so it's going to send a message to somewhere that can do something about it. So it sends a message to your skin, mostly to your skin. So your skin blood vessels, when you work out, your face gets red. The reason your face or your arms or whatever, the reason you get red is your blood vessels will expand. So then your blood vessels are closer to the outer layer of your skin. So when your blood vessels expand or dilate, they get closer to your skin, the blood is moving faster, your face gets red. And if you are light-skinned, you're going to see that redness more than someone that's dark-skinned. It also signals to your sweat glands, and you start to sweat, which is a way that your body releases heat. So that would be my effectors. My blood vessels are going to expand, help cool me off, and I'm going to start sweating, which releases heat and helps me cool off. Response, that heat is lost, it leaves your body, and pretty soon I'm back to normal. Opposite, I go to a conference, and it seems like every time I go to conferences, they have the air on really cold. I assume to keep you awake, I don't know. But body temperature drops. I get cold. Receptors, those thermoreceptors in your skin, pick that up. Your body's getting cold. Sends it to your brain. Your brain processes this and then sends sends it out to your effectors. So here your skin, your blood vessels actually shrink, which is why when a person like gets very, very cold, their skin turns blue because those blood vessels have shrunk so much that you don't hardly even see that color. When your blood vessels shrink, they're hidden deep inside. It's like it has a thicker layer of skin to keep it warm. So my blood vessels constrict. My sweat glands are going to be shut off. I'm not going to sweat nearly as much. And then the other thing, your muscles are going to be affected. So you might get goosebumps. Goosebumps are little muscles, and we'll talk about that later, but they're little muscles that contract, make your hair stand up, and when a muscle contracts, it produces heat. So goosebumps are going to produce heat. If you actually shiver, you're so cold you shiver, that is basically a contraction of your muscles that also help to generate heat. So eventually, hopefully, you get warmer, your body is back to normal, and everything then is the same. So that was an example of negative feedback. I get cold, my body produces heat. I get hot, my body starts to cool off. There are a few positive feedback mechanisms, which means more of the same. So what happens is, instead of trying to bring things back, it pushes it further away. I'm going to talk about the examples first. So labor is probably the most common example that I think of. When you're pregnant and your body goes into labor, labor is not normal. Your body, that's not normal for the body. And negative feedback would be to stop that. Well, instead of stopping labor, your body produces more chemicals that continue those muscles contracting and actually increase your labor pains and contractions. Another example would be blood clotting. When you cut yourself, you don't want to bleed profusely, so when your blood starts to clot, you're going to have more clotting to stop the bleeding. So positive means that you're going to get, it's going to be unstable because it's not normal, but you're fixing something by doing more of the same. If I don't get enough blood to clot, I'm going to bleed to death, and you don't want that to happen. If I don't go into labor, I'm going to keep this baby inside of me forever, and that's not a good thing. So those are the two examples of positive feedback. And that is where we will completely stop for today.